Thank you very, John. Thank you very much, and thanks for having me. I enjoyed the first part to get a bit more insight in what else is happening and what kind of crew I have in front of me when presenting. At least for those now present. Of course, I don't know on the YouTube channel who'll be watching, but so without further ado, I'll share my screen, and I think my face will disappear. That's the only disadvantage of Zoom, I think. There you go. Yeah, share that. And now you should be able to see something.
Your face is still visible. I can't guarantee whether it will be visible in the recording, but I think it will be.
Yeah, I also don't know, but I won't make too many weird gestures then. All right. So let me start the screen show. Yeah. So as you said, my name is Kasper Kok, and I work in the Wageningen University already for quite some years. Currently in the chair group Environmental Systems Analysis, which pretty much also describes what I do and what kind of topic I find interesting, are integrated systems. That's why the word integrated was also in the title, even though it's not in my title here. And most of the presentation will be somewhat more of the background of scenario development and what scenarios actually are. And then I'll have a few slides on the chemical pollution side, and that's why my work package fellows are listed here as well, because I'm by no means an expert on chemicals, and I'm already jealous to be looking at these names. I hear your hesitation and say, is there any other way I can say Kok in English? No, there's not. Could try Cook, but which is what it means. Other names I find are much nicer than my short name, but that's what we have to do with. All right. So here's a bit of personal background. I am actually a tropical ecologist by training. So I've done experimental work in the field, mostly in Latin America. And then I spent about a decade as modeler. So I'm pretty much familiar with most of the terms that I saw coming by. I also like that kind of audience because where I come from is really very much the modeling world. And what I do very much now is not the modeling world. And those are two worlds that are sometimes very far apart, but very, very interesting to couple. And that's also a little bit the focus of my whole presentation. Because currently I really specialize in co-production of scenarios very much with stakeholders. So I'm very interested in their view of what the present is and their view of what the future is. And I am fairly experienced in developing a range of different types of scenarios, which is very nice when you focus on a method. You can apply it in a range of different fields, including chemicals. So it gives me quite a broad view of different topics and how they could relate to future questions, let's say. And personally, I'm really fascinated by transdisciplinary research and the struggles to deal with stakeholders, and the confusion when you talk with people from other scientific disciplines is super fascinating to me. But what I'm not is an expert on chemicals. You might slightly wonder why I've been invited and not somebody else, and that actually kind of goes back to the fact that Wageningen is this super small city where you can do lots of very nice networking activities just simply by being a father. So I know Paul as a father of 2 kids rather than a professor at the Wageningen University. And then when you get at a personal level connected, then that can lead to these kinds of interactions, which is actually quite nice. But that on aside. So what I'd like to do in the next half hour, 40 minutes or so, is spend about half the time in kind of setting the stage of what, in my terminology, scenarios are. Because certainly when I listen to model-based projects, you get a lot of very precise descriptions of what kind of model people are using. And you see that the equivalent scenarios has not been developed quite as well. You very often still see like, oh, I'm developing scenarios. Well, I'm also developing scenarios. We're doing the same thing. Whereas with models, that would never happen. Because it is a conceptual model, a mental model, experimental model, simulation model, and what have you. So for scenarios, in a sense, the same counts. So first I want to conceptually put that down, what I think scenarios are, what they should be doing, and therefore what types of scenarios you have. And then I'll have in the second half a number of examples of how that has been worked out in projects I've been involved in. All right. So, all the way back to a bit of history, the word scenario exists for a very, very long time. And it actually comes from dramatic art. So even before you had movies and Oscar nominations for the best scenario, you already had theater plays which all have scenarios, which in essence is the outline of a plot. And in essence, that is still what scenarios are. Be them qualitative or quantitative, they kind of tell you some kind of plot of how to go from now to the end of a theater play or a movie or the future. And that's basically what the word has been until roughly the 1940s. And then came the very first, arguably the very first time that scenarios have been used outside the realm of arts. And it was the Manhattan Project. And I think it's also arguably one of the worst examples to use scenarios. Because for those of you that know your history, the Manhattan Project was a little think tank towards the end of World War II. And this particular question they asked themselves was, would it be a good idea and what would happen if we would drop an atomic bomb on Japan? Discussing, will this end the war quicker, and will it in the end save people's lives? And they decided it was a very good idea to not only drop one atomic bomb, but to drop 2 atomic bombs. Well, history has shown us what the pros and cons of that were. You can have lots of different opinions about it. It did end the war, that's for sure. But I think there are some side effects that I didn't necessarily oversaw at the time. Right. So ever since, I think, scenarios have been used for strategic planning in the military. And I would be very surprised if the best scenario experts are not still working in military. It's all quite top secret, so it's very, very difficult to get any real feel for what national and international scenario users are in the military, but rest assured they are going ahead. But for decades after the 1940s, that was the only place where scenarios were used. It was not until the 1970s that the businesses, they were actually the first to become interested. So science was still nowhere to be seen. They became interested in the what-if type of scenarios. And the story has it that the Royal Dutch Shell became from a medium player on the oil market to one of the business leaders by using scenarios. And this specifically tied to the first and second oil crises that happened in the late 1970s and mid-1970s, where OPEC decided to limit oil production and therefore the prices skyrocketed and there was a huge shortage of oil in many places in Europe and in the Netherlands specifically. And the story has it that Royal Dutch Shell had done a scenario planning exercise. So they actually already kind of played out that kind of future before it happened. So when it happened, they were much more ready to act quickly. And because they acted more quickly, they actually became the leader of both scenario approaches, but also in the oil industry. Then we have to go a little bit further. Arguably, the very first scientific exercise that used scenarios was the very famous report, Limits to Growth, by Meadows and Meadows, in which they first started wondering if perhaps there's limits to how many people the Earth could support. And that actually for a very long time was the only real serious scientific application. And it really took until the mid-late 1990s before the first time that seriously global environmental scenarios were being developed. This was also a very small but extremely influential think tank called the Global Scenario Group that really made the first set of global environmental scenarios scientifically supported. And from then, it really exploded. And I think the key word is one that I don't even mention here is not global environmental understanding, but is really climate change. As climate being a very slow process and very uncertain in which way it will really go, models and otherwise were developed to better understand. The scenarios became a key part of understanding climate change into the next 50, 100 years. But it's across the board right now. There's so many papers on scenario development that I can't really keep track. And I've been asked to review so many to just see the tip of the iceberg of how many people are now using scenarios to understand what future needs might be. Right, that's probably too much said. Okay, one thing I'll do right now is something that I've always been told not to do. You put too much text on one slide and then you read it all out. But still, I find this quote so important that I'll do exactly that. So Gilberto Galopin was one of the founding members of the Global Scenario Group, said back in 2002, the world is now moving through a period of extraordinary turbulence. The speed and magnitude of global change, the increased connectedness of social and natural systems, and the growing complexity of societies and their impacts on the biosphere result in a high level of uncertainty and unpredictability. Right, let me unpack that for you. Three things that I think stand today, and perhaps even more so than 20 years ago, is the incredible high speed of change, particularly technology, social media, etc., but it goes for other sectors as well. Second, that systems are connected. Arguably, and I think many people agree now, we are no longer in the Holocene, we are in the Anthropocene. Coined also about 20 years ago, many people use that term right now, and saying we are in a man-made era. All changes are somehow pushed by changes in the social domain rather than in the natural domain. And because there's super connectedness between the social and environmental system, we also get higher speeds of change. And because of that connection, we get higher impact. So that's the one half of the story. The other half really is the key word that relates to scenarios, and that is uncertainty. We simply do not know what the future will bring. Systems are so complex that we really can't tell how the world will look like, or a country will look like, or even smaller regions will look like 50 years from now. It is simply unpredictable and therefore uncertain. All right. So, scientists being scientists, we like our frameworks and graphs and figures and putting it all in boxes. So here are a few attempts of frameworks that show when to use scenarios. So here's one from Gary Peterson, 2003. He had two axes. One was the axis on uncertainty, either high or low, and the other one he called controllability. And he argues that scenarios have been used when have to be used when uncertainty is high, but when controllability is not high. And by that he means if there is a single actor or a very small group of somewhat predictable actors or influential actors, then you can act directly. Then do adaptive management. Don't go for scenarios, because some of the aspects of your system are actually known, because they're so easy to control. The second one that I want to show is one that came from the Millennium Ecosystem Assessment. They similarly have an axis that's called uncertainty, and they similarly argue it's either low or high. And then their second axis is complexity. So they argue that scenarios have to have somewhat higher level of uncertainty, but also a somewhat higher level of complexity. If the system's uncertain, but not complex, you can still try to do predictions and forecasts rather than scenarios. They're also saying it's not unimportant later for the story of chemicals that if uncertainty is too high or your system is too complex, it becomes really hard to do anything scientific. And you kind of enter this realm of speculation where you can say something about the future, but it's going to be really hard to do something with any level of structured understanding because you don't really know. All right, and then there's a third one. Don't want to go into too much detail there. The words are a little bit different, but again, you have this one axis in this table, which is uncertainty. Here's a second axis they used in tabular form, which they call causality. I think you need to have some higher level of causality, meaning you need to kind of understand a bit where the system is going. If there's no causality, then it becomes, again, rather speculative on what it is you can say. Right. So, what do people agree on in literature? They agree that scenarios are a good tool when uncertainty is high. That's why I usually repeat that about 5 times. If that's the only thing you take from this, use scenarios when uncertainty is high. And there seemed to be some level of understanding and agreement that there is a second axis, and it's some word that starts with a C. But seriously, it is something that has to do either with the complexity of the system being quite high, the causality to be high, because you need some understanding of that complexity, and the controllability should not be too high, because if there's only one actor that changes it, then scenarios become useless as well. Okay, but there's a lot of literature underlying this and when actually are scenarios a good tool. So, people can agree kind of when to use scenarios. They have a much harder time to agree what a scenario actually is. I was the CLA of a chapter in the Millennium Ecosystem Assessment on scenarios, and towards the end of the journey, I went through 100 pages of text and filtered out all the different definitions of scenarios that I encountered. And there was about a page, 10, 12 different definitions with overlap, but definitely none of them was the same as any other. And if I would summarize across all those different definitions, kind of two surface. And these are the two I want to mention here. So one way of saying what is a scenario is to say that scenarios are plausible descriptions of how the future may develop based on a coherent and internal consistent set of assumptions. Okay? And when I say, listen, if you see this type of definition, what you can try to do is take out the word scenario and put the word model there. And a model is a description based on a coherent and internal consistent set of assumptions. In other words, those people that use this top definition are more often than not people that also use models or even see scenarios as model output or model input or something that always comes together with a modeling exercise. Okay? Nothing wrong with that, but that's one type of definition that you often see. But then there's the bottom one, and the bottom one is very different. And that states that scenarios are credible, challenging, and relevant. And what are they? Well, stories, and they could be words and they could be numbers. They're not entirely uniform on whether they should be qualitative or quantitative, but what they do emphasize is that they need to be credible, challenging, and relevant to the stakeholders or the people that use these scenarios. So here the focus is much more on the user than on the actual product. Sometimes also arguing that, people are not internally consistent. People are not coherent, certainly not if you have a broad group together. They're anything but coherent together. So why would a scenario about the future be that? That's simply not how the world works. Okay, but you see a little bit of a split between those two different types of definitions, and you see that continuing if you start talking about why you are actually using the scenario. And so if you talk to an environmental scientist, I think by and large almost everybody that I'm talking to right now is an environmental scientist, would say, well, a scenario is a good tool to do an integrated analysis of some complex problem. And what they mean to say also is that what you do is you develop some kind of concrete output, a map of land use change, a map of climatic change, definition of extreme events and how they change into the future. It could also be a story, but it's some concrete outcome of a future situation. Whereas for a social scientist, that is all but irrelevant. And they say, well, I use a scenario because it's such a good tool for communication. It's a perfect tool for conflict management, long-term participation, science policy interfaces. So I'm seeing the scenario as something that's more the process of bringing people together and have them talk about the future than it is about making something together that you're then going to use. Okay, and again, both of them are valid. And certainly not one is less than the other. And certainly when you include stakeholders, you have to be extremely careful in making sure that the process has a quality control and that it is a good tool for communication. Because otherwise, you are missing the point and you might developing products that are actually not good. So if the process is not good, how can the outcome be good? So they often go kind of hand in hand together, but they're quite different. Right. Many review papers have been written about the different types of scenarios and how you can categorize them. This is my favorite one. It's almost 20 years old. And it's still the one that I find best captures the entire diversity of everything that you could potentially call a scenario. It's perhaps not surprising, not totally unrelated, written by somebody who was working in the same institute I was at the time in Maastricht. But it shouldn't have anything to do with it, really. So what he did is he said there's three things that actually start defining what type of scenario you will be developing. And the first one relates to the project goal. And the second, I'm not going to go in much detail here, just showing you what's in the paper as well. 14 different categories based on the goal of the project, the design of the process, and the content of the scenario that you want to develop. Each one of those would merit a discussion of 5 minutes, and I'm seeing I'm already late, so I'll move on to the next slide, in which I pick out some of the more important characteristics that anybody should be discussing when you talk about scenarios. Other review papers have very often taken this very first heading here as the key branching point into what scenario will you develop and will there be stakeholders and what will you be doing with them, is what question do you seek to answer? Is this the question what should happen, or is this the question what could happen? And they're very different questions, and they lead to very different types of scenarios. And it's mostly this category one, are norms included or not? I want to stay below 1.5 degrees as agreed in the Paris Agreement. That's my vision. So that's where I want to end up. Now, what do I need to do to have 2 degree of warming 20 years before? And what do I need to do then right now in mitigative measures to make sure that I reach 1.5 degree warming? Or do I say, well, next month the elections are in the US, we'll see what if Trump gets reelected? Now, what if he starts a full-blown trade war with China? And what if global trade collapses? And what if because of that, the Netherlands also starts losing quite some revenues? And what if? Is a very different type of question. And it's instrumental in deciding what kind of scenario you want. Now, the second big choice is, do you want a scenario that's co-produced and where you involve stakeholders and their knowledge in discussing what the future may be? Or do you want solely models? So is this method of data collection participatory or desk research and model-based? And is the data mostly qualitative or quantitative? And then there's a third aspect where you really have to decide, what is it you want? Is this a sectoral model, or is this an integrated story that involves all aspects of society? And do I want crazy scenarios that go far off and include all kinds of surprises, or do I want to stay relatively conventional? Anyway, all these characteristics kind of are good building blocks to understand what it is you actually want from scenarios. Also, the examples, I'll focus a bit more on what also surfaced in our discussions with work package 3. Now, where's really the crux? It's really in this, do I do qualitative or quantitative scenarios? And do I involve stakeholders or not? And if so, when do I involve them? And for what purpose? And that has been discussed a lot in literature, how to combine qualitative and quantitative scenarios. And what emerged was a general approach called the story and simulation approach, in which you try to combine stories and models in an iterative procedure that would in the end yield one set of scenarios. Now, without going into too much detail, you first have a number of steps that develop narrative storylines with stakeholders, usually in workshops. So you come out with a set of stories for the future. And then what you do in step 4 is you have experts, modelers, quantifying those stories. That's the model input. And that is being fed to models. models produce outputs and indicators and what have you. Those are being brought back to the stakeholders that made the qualitative scenarios. And they might say, well, if this is your understanding of how the world will change, then maybe we should change our story slightly because we made some assumptions on things that we didn't really know that we now understand should be changed. If we change the stories, then the model input changes. If the model input changes, the model output changes, and you can have, again, a discussion with your stakeholders. So the most important step of this whole framework is actually the one you can barely see. It's step 7, where you say repeat. You iterate between the modelers and the stakeholders. And if you do that a number of times, and the number seems to be at least 3, which not all projects manage, you can start getting more consistency between the two types of scenarios. And in the end, you can have a scenario product that both has plausible and internally consistent part given by the models, but also a part given by the stakeholders, which is credible and challenging and relevant. So you try to get the best of both worlds of those definitions of scenarios. So that's how it conceptually is being put. Let me see how I'm doing time-wise. Horrible, of course. Yeah, I need to go much quicker if I have any time for discussion. I'll race a bit through different examples just to give you a flavor of what scenario development has been and how taking different choices and what type of scenarios you want leads to different products. So this was an extremely large undertaking. Took more than 5 years. It was not intergovernmental. The IPBES is now. They tried to do something similar to the IPCC, hoping to be similarly recognized, which they never were. And I'll forget about the rest. They have a conceptual framework, which I only show. No, I show it for 2 reasons. The one is the Millennium Ecosystem Assessment got famous for only one thing, arguably, like over the years, and that is ecosystem services. It was kind of coined and elaborated in this undertaking, where hundreds of scientists were working on it, and it took off from there. But its inception was within the Millennium Ecosystem Assessment. And what I like about the MA is their focus on my other pet word, which is multi-scale. Systems are complex. Very often they cross scales. And crossing scales is a whole other ball game of very interesting issues that also relate to what we do with chemicals. Not enough time to go in detail. They had 4 storylines. You very often see that. You focus on 2 different uncertainties, and they make a cross, and the cross gives you 4 different quadrants, and those become 4 different scenarios. Very interesting reading material. Not at all outdated. They could all still be the future as we know it. But more importantly, what the MA also did is they went through this entire story and simulation approach. So they had their storylines. The storylines were translated into model inputs. The range of different models was run, and lots of model outputs were produced. And if you pay close attention, you see that the one arrow that's missing from this particular slide is the feedback from the model outputs back to the stories. And that was because storylines had to be developed, models had to be developed and adapted. And in the end, there was, even though this was a multi-year project, not enough time to do a proper loop back from model output to the stakeholders, changing the storylines, changing the model inputs, and changing the model output, unfortunately. But the approach was there in general. So here they really wanted to do everything. It was multi-scale. Interestingly enough, what you see is that they went back in the MA sometimes to the original definition of a scenario, saying, well, this is now the plot, an outline of a theater play. And so let's make little theater plays to make stakeholders understand what those scenarios are and what the future might actually bring. And depending on the level of expertise that's in the room, this might be a better approach than show some map or nice colorful moving output from a model. Just a few slides in between. I saw at least one question which was on the RCPs. I don't think they can be ignored anymore. There's a new set of climate change scenarios that are called the RCPs and the SSPs. And you see that with big intensity increases, people are using those as the new set of global scenarios that are the standard if you want to use any scenarios. So this is more name dropping than any background on what these scenarios are. Originally, there were 4 RCPs. Now there are a few more. So you can see we were quite pessimistic at the time as to what emissions would do, because 3 are increasing up and beyond 2100. Even though the RCP 4.5 is leveling off, it's not decreasing in 2100. And that's only the radiative forcing. So the temperature increases that will come after and extreme events that would come after that would keep on rising way beyond 2100. Now there's another one that goes a bit lower, but it's generally speaking not a positive outlook of what emissions will do to radiative forcing. And then, and this is my own realm more, there are 5 SSPs. Their stories, their trends, there are also quantifications of key parameters such as population and GDP. Will not say anything more about it. The nice thing of the new generation of climate scenarios is that you need to combine. First, you separate out climate effect from socioeconomic effect, but later when you want to talk about impacts, obviously you look at the combined impacts of socioeconomic development and climate. So then you need to look at every box here and say, well, which box do I want to be, and what combination of climate forcing and socioeconomic change is that? And the novelty being that one socioeconomic future can lead to many different climate change worlds. This is not a one-to-one relationship. And that was the key innovation actually in those scenarios. And I'll skip that one. Now, I shouldn't have to explain a lot, in fact, on what scenario it would be if you would focus immediately on models, just to give you a feel for how you can pick that out easily. Nicely, also in the modeling world, multi-scale has been a big issue for the same reason. So you see the same words coming back as for projects that are more qualitative. In this case, it was land use change and land abandonment in Europe. So they said it was multi-scale for a variety of reasons. They said we stick to models. They were quite clear on saying, well, these are what if. We're exploring, we're not doing anything else. They repeat that here. So it's no desired futures or undesired futures. So this is not normative. This is simply just what if, what if, what if, and what will the world in 2050 look like? And why? Because we want to deal with uncertainty. And here you see the giveaway. They say what we're going to develop are plausible futures. And then I say, aha, you're modelers, because you love the word plausibility. Well, they link different models across different scales. This is their view of a scenario. When I talk to modelers, very often what they have in mind is model input. It's not a story. There's not a set of developments. It's not climate. It's not socioeconomic. No, it's a set of model input variables. In this case, the increase and decrease of arable and pasture land across Europe in the EU 25. Okay, using the old scenarios. Now, and you're not the group I have to convince that there is a benefit of having quantitative scenarios, because obviously you can, in this case, run land use change models across the EU 25 at the time. I think they fixed the whole of Switzerland by now, and I think Norway is probably okay, also in, and you show very detailed where land abandonment will take place. In this case, it's the blue color, so you see land abandonment happening well across Scandinavia, Ireland, one of those countries that start emptying. At the same time, you can also see quite detailed where urbanization in this particular scenario will take place. As the whole of Flanders becomes one big city, the Ruhrgebiet starts expanding, but also quite large parts of the green heart of the Netherlands are disappearing. Okay, so it gives you all kinds of information that qualitative scenarios would not. But having said that, my whole heart is more with co-production, participatory methods, and intense stakeholder participation. This is one of the earlier projects I did there. And similarly, you start by acknowledging that there is multi-scale aspects to this. There are European developments that will lead to Mediterranean developments, but in the end, if you go down to the local level, that's where the real change happens. you want to understand land degradation, desertification, the tourist sector, agricultural practices, then you really need to go down to the case study level, which was very strongly advocated in this project. As a side note, we had one of our case studies on the island of Lesbos, and we decided to do relatively conventional scenarios at the time. And of course, if you would have a look at anything that happened in the last 5 years in Lesbos, needless to say that we were completely wrong with our scenarios. You also get very humble and sometimes seeing what big developments take place and how the reality of some places becomes entirely different than anything you ever imagined by looking at scenarios. But that is a side note. So, in the world of participatory scenario development, I'm often known as Mr. Post-it, and I love the simplicity of the methods. I don't need any technology, I don't need any computer, I don't need any data, I just need a bunch of stakeholders, and I ask them what's important. Write it down. I want the whole diversity of all your opinions, worldviews, fears, hopes, desires, put them on little Post-its, and we'll start from there. From the big picture of all this diversity, write down whatever you think is important. And then we go into a slow process of grouping those factors back together and saying, well, here's a few that were on climate change, this all related kind of to the political measures, agricultural, spatial planning, water was a big issue. And out of those clusters, you start developing simple conceptual models of how the world works according to groups of stakeholders. And important on this slide to note is that we came in with a project on desertification, population, and land use change. And we came out with a project on water. Perhaps not surprising that in the Mediterranean, water is such a central issue, but we really had to shift both our terminology as well as our focus from desertification to water issues. And with that to water policies and spatial planning policies that were quite a bit different from what we initially wanted, which sometimes happens if you work with stakeholders. Okay, unfortunately, no time to go into this. Beautiful methods, scissors and magazines to make future scenarios, which enables you to involve also people that are semi-illiterate. They work wonderful, and usually nobody wants them because they don't want to go back to kindergarten. But they give very rich products that are very useful. All right, on to the last example, and I can be relatively quick because Alice presented something that used both the same story and the same picture also, so I hope it can be done in just a few minutes. So here's the terminology. Let me start with that. It's a bit of a horrible, the IPCC is very good in having horrible terminology anyway, and usually too many abbreviations. They shy, I don't know, I went over it very quickly, but I showed a few slides that had at least 10 abbreviations. And I think there was barely anybody in the audience that understood all of those 10. So they try to really chase away people by being too much in their own lingo. But what they mean with extending, saying, well, there is a basic set of SSPs, of socioeconomic scenarios that are relatively generic. They give some information on future trends, but they leave a lot of things open. And they said to the community, please extend those. And what that they meant is make other versions that are non-global. I have my own version of the SSPs for Europe that we developed. Or for a country or for a smaller region. You can extend them geographically. But you can also extend them sectorally. Well, they're very, very generic. But you could do something that is specific for water, or that's specific for tourism, or that's specific for whatever sector, climate related or not, is actually kind of beside the point. And then you can also extend it globally by including other factors that might not have been considered before. So clearly for chemical pollution, I find this is a sectoral extension. The question came, is the paper going to be global or not global? And I wrote it down. It's something we discussed before, but we didn't completely decide on. For now, I'm assuming that the answer from Alice is my answer as well, is that this is going to be a global set of scenarios and where we take a sectoral extension. Now, how could you do that, the sectoral extension? I think by and large, there's three ways. You can say I go totally quantitative, which would fit very well, I think, with a lot of the other examples in Ecorist. Well, you quantify whatever relevant elements you have of the SSPs, you very quickly make model input, and you run quantitative models. And you estimate chemical pollution based on whatever data and indicators the models give you. Or you could say I go completely the other way, and I do qualitative. I take the qualitative narratives from the SSPs, I rewrite and expand them to actually have a lot of rich information on chemical pollution. But they're stories, and that's what they are. You can use them for all kinds of purposes, but the main purpose for now is stories. Or you can try to do something that actually serves both purposes. Because I think with the PhD students in the work package 3, we get the strong feeling part of them are going to do quantitative work. So it would not make sense to only go qualitative. But if you also want to do qualitative work, it does not make sense to only go quantitative. So you try to do something that both does justice to the socioeconomic changes in the narratives, so stay qualitative, but you also want to do something that's in the end useful for models. And these are some kind of, they almost look like eggs, they're not intended to be that, but to show you a little bit of what that would mean. So you can only be on the left side. This is the narrative side. So I start saying, well, here's all the SSP elements. Now let's identify that subset of elements that's actually relevant for chemicals. A lot of information is not really. So I can skip that, that I don't really need to look at that. But from the other side, you can start looking at all the different chemical components. And it's a very long list. And also there, I saw the question earlier this afternoon, what about? And why didn't you? And that's one of the big struggles, I think, is now what to limit yourself to. But one of the ways to limit that can be by looking at the future and looking at those chemical aspects that are actually uncertain. The one that I like most is back to the diagram from the Millennium Ecosystem Assessment, where if you go too far out, go away. You go too far out into the realm of uncertainty, and it becomes speculation. My computer is telling me that it really needs to download software, so it's kind of distracting me a bit. I hope you don't see all of that. So there is a subset of those chemical aspects that are not too certain, because we already know what's going to happen, but they're also not too uncertain. And that subset is extremely important to identify. So what you have not done until this point is to make an overlap. You haven't looked at how the SSPs would relate to those chemical aspects. So in the end, you can overlay them and you can say, well, that's the area. That's the area that will give me all the aspects from the SSPs where I can link SSP information to chemicals. And it would give me uncertain future outlooks, which is what my key is, because uncertainty is in the end the key from scenarios. It doesn't allow me to postpone an installation, which I'm still going to try to ignore until it starts doing weird stuff. So this is the same table that Alice also showed, which kind of shows how you combine those. So my two pictures are the one on the left side, where you start discussing which SSP elements are important. And the other one starts on the right side, like what aspects of chemicals are actually important and uncertain in the future. And how can we make those links? Those links with, in the end, the idea of, well, here on the left is an example from the global scenario group. But in the end, what you're looking for is a rather large table, I imagine, where you have the different SSPs and the different chemical aspects, and there's trend indications. Where in SSP1, pesticide consumption might go down, as Alice was explaining, and in SSP3, it might go up. In other scenarios, it might actually be also a question mark, because this can also be agenda setting. And there can also be cells in this table where you say, well, actually, I just don't know. And we need more research here to see what future trends might or might not be. Okay? So, last slide, where I summarize a little bit all the things that I threw at you in the last 40 minutes. I hope it's not been too much. So my starting point is that many of today's problems are complex. And that creates a fundamental uncertainty on what the future will bring. And that makes scenarios an excellent tool to use, with the connotation that, and I heard the word decreasing uncertainty, and that's why I put this in last second. Scenarios are not decreasing uncertainty. At least not scenario uncertainty. We fundamentally do not know what the future might bring. And we can have better models, but we still don't know. There is also model uncertainty. If your model is bad, you're very uncertain what's going to happen. If your model is good, you're less uncertain. So by increasing your model confidence, you will decrease model uncertainty, but never scenario uncertainty. You can structure it, you can indicate it, you can never decrease it. All right, so there's many definitions, many types of what scenarios, and there's not an exact consensus, nor should there be. Story and simulation is a very often used approach to link participatory qualitative scenarios and quantitative models to kind of get the best of both worlds. And the latest global climate scenarios are increasingly extended. You'll see that word popping up over and again to cover other scales and to cover other sectors. But this is an unexplored research area, and that's the main reason I think that the paper that I've been discussing with the 3 PhDs is going in that direction of extending SSPs. I think that is my last slide. Yes, it is. So I'm sorry I took too much time.
No, that is all right. Thank you very much for the extremely interesting presentation. The historical context for how scenarios came to be used within science is really interesting. So thank you for including that. I think we have time for one question. I'd like to give time for a little bit of a break before Antonio's presentation that's slated to start at 16:20. So I think we have time for one question, and then of course we have all week with coffee breaks, etc., to ask any others that aren't able to be asked now. So we'll check the chat box if anyone has.
No, I saw hands, but no chat.
Yes. I have a quick question about within the context of coronavirus, that sort of, is that something to that level of potential disruption of potential scenarios? Has that been incorporated into any scenarios? And if not, how do you see events like that sort of impacting scenario development going into the future?
Yeah, so the first answer is, of course, we're doing it right now. We had a paper that was about to get published in Nature Climate Change when Corona started, and then we held off the publication, and we included a COVID-19 box in which we actually discuss exactly the questions that you have. And so, yes, it does. But of course, climate change specifically is a very long-term and slow process, and how you match that with short-term extreme events. And of course, this is extremely relevant for this entire project as well. Where extreme events are variability, but of course the variability also changes. There's a specific corner of research in foresight methods which relates to wildcards. There is a wildcard database of like 8,000 different wildcards that can happen. And those are all extreme events. And we all agree that extreme events very often trigger change. So there's a very strong, but it's a debate because you also enter a different community. Yeah? The risk, that's why they're separated here in this project as well. The risk community looks at the tails of the distribution. They want the 1 in 1,000 year event. They want the extreme heat wave. Whereas if you look at the SSPs, it's the slow changes. So they partly have different purposes, but they're also, they're two sides of the same coin. And you can't really ignore the other side. So it's, I guess it's a bit of a challenge for this project as well. The short-term extremes and the long-term changes, and where do you bring in what without wanting to do everything at the same time. But there's a lot of examples on COVID. I mean, everybody who has a paper on scenarios now all of a sudden needs to bring in, and there's a lot of discussion. Yeah.
Yeah. Thank you very much. I think it would be good if we take about a 5-minute break. Antonio, is that okay for you if we start, I guess it would be 3 minutes late?
It's okay.
Okay, so I will go ahead, I'll leave the Zoom room open, but we'll plan to go ahead and start then at 16:23.
All right.